I will explain the most dangerous cosmic phenomena, from terrifying to hellish nightmare, and at the end of video, I will revealing a hypothesis that Stephen Hawking once warned about, that such an event could instantly destroy the universe without warning. Dark matter. What if the most important thing in the universe is something you'll never see? Dark matter is an invisible form of matter that makes up most of the universe's mass, but cannot be directly observed. We are outnumbered, not metaphorically, literally. Everything you've ever seen, stars, planets, galaxies, that one embarrassing memory your brain replays at 2 a.m. All of it combined makes up a tiny fraction of what actually exists. The rest? Dark matter, invisible, untouchable, completely uninterested in explaining itself. It doesn't emit light, doesn't absorb it, doesn't interact with normal matter in ways we can easily detect. It's like the universe has this massive, hidden framework holding everything together, and we're just guessing where it is based on how things move. Galaxies spin too fast, way too fast. If only visible matter existed, they should tear themselves apart, but they don't. Something is providing extra gravity, extra mass, extra something. And we call it dark matter because, honestly, what else are we supposed to call a thing we can't see, touch, or fully understand? And here's where it gets uncomfortable. It's everywhere, surrounding galaxies, threading through them, possibly passing through you right now in ways that don't even register. You're existing inside a structure you cannot perceive, like a character in a game who has no idea the engine is running beneath the surface. There's something deeply humbling about that. And by humbling, I mean mildly horrifying, because it means our understanding of reality is incomplete in a very fundamental way. We're mapping shadows on a wall and pretending we understand the objects casting them. There are theories, of course, exotic particles, alternate frameworks, entire branches of physics dedicated to figuring out what this stuff is. But so far, nothing definitive, just more questions stacking on top of each other like a cosmic conspiracy that refuses to resolve. And the danger isn't that dark matter is actively trying to harm us. It's that something this massive, this influential, this essential to the structure of the universe can exist almost entirely beyond our perception, which raises a question I don't particularly enjoy thinking about. What else is out there shaping reality that we haven't even guessed yet? Rogue planets. We call planets homes, but some planets have no home at all. Rogue planets are planetary bodies that drift through space without orbiting any star. There's something profoundly unsettling about the idea of a planet with no sun, no warmth, no central anchor, just a massive chunk of rock, or ice, or something worse, wandering through the void like it got kicked out of its own solar system and never found its way back. We like to think of space as structured. Stars, planets, orbits, everything moving in these neat, predictable patterns. Rogue planets break that illusion. They're the cosmic equivalent of something slipping through the cracks and deciding to keep going. And they're not small. Some of these things are the size of Jupiter. Entire worlds, complete with atmospheres, maybe even subsurface oceans, drifting in absolute darkness. If you stood on one, assuming you could survive, which you absolutely could not, the sky wouldn't glow. There'd be no sunrise, no sunset. Just an endless, suffocating black. Now imagine one of these things passing through a solar system. It doesn't need to collide with anything to cause chaos. Its gravity alone is enough to start rearranging orbits like furniture in a room it was never invited into. Planets get nudged, asteroids get redirected, stable systems become less stable, and less stable in space is just a polite way of saying things are about to go catastrophically wrong. There's also the possibility, and I hate this, that a rogue planet could pass relatively close to Earth without us noticing until it's too late. Because detecting a cold, dark object against the backdrop of space is not exactly easy. It's like trying to spot a shadow in a room with no lights. And even if it doesn't hit us, even if it just swings by, the gravitational effects could be enough to mess with our orbit, our climate, our entire delicate balance of existence. All because a planet somewhere at some point lost its place, and now it's just drifting. Neutron stars. Sometimes the smallest things are the hardest to escape. Neutron stars are ultra-dense stellar remnants where a single teaspoon of matter weighs billions of tons. I need you to picture density, and then I need you to throw that picture away because it's not even close. A neutron star is what happens when a star collapses so violently that atoms themselves give up. Electrons and protons get crushed together into neutrons, like reality is being compressed into a format it was never meant to use. This thing is small, city-sized, that's it. You could theoretically fit it into a major metropolitan area, which sounds almost manageable until you remember it still has more mass than the sun. So now you've got this tiny sphere with gravity so intense it doesn't just pull, it demands. You don't walk on a neutron star, you don't land on it, you become a very thin, very immediate smear. The gravitational field is so extreme that even standing near it would turn you into a cautionary tale told by physics professors who've lost the will to simplify things. And then there's the spinning. Some neutron stars rotate hundreds of times per second. Let that settle in. Something the size of a city spinning faster than a blender on existential steroids. The surface speed is absurd. The magnetic fields? Even worse. They twist and snap space around them, creating beams of radiation that sweep across the cosmos like lighthouse signals from something that absolutely should not exist. These are pulsars, cosmic metronomes ticking with terrifying precision. If one of those beams hits Earth directly at close range, it's not a light show, it's a problem. A very immediate, this is why we can't have nice things kind of problem. And then there are magnetars, which are neutron stars that decided regular insanity wasn't enough. Their magnetic fields are so strong they can distort atoms from a distance, not metaphorically, physically. If one got close enough, it wouldn't just affect electronics, it would start rewriting the structure of matter itself. There's a quiet arrogance in how stable we assume reality is. Neutron stars exist purely to dismantle that assumption, because somewhere out there is a dead star that didn't stay dead. It collapsed, compacted, and came back as something denser, faster, and infinitely less forgiving. And it's spinning, always spinning. Supernovae. The universe creates stars by violently killing them. Supernovae are massive stellar explosions that can briefly outshine entire galaxies and flood space with lethal radiation. There's a very specific kind of arrogance in calling something just a star when that just a star can end its life by detonating with the energy output of billions of suns combined. A supernova isn't a death. It's a statement. Stars spend millions to billions of years quietly fusing elements, holding themselves together in this delicate balance between gravity and pressure. And then, eventually, something tips. Maybe it runs out of fuel, maybe it accumulates too much mass from a companion. Whatever the trigger, the result is the same. Balance collapses and the star decides to go out in the most violently theatrical way possible. The explosion is so bright it can outshine an entire galaxy. For a brief, absurd moment, one dying star becomes the main character of the universe. And if you're close enough, which I would strongly recommend not being, it's not a light show. It's a sterilization event. Radiation floods outward. Shock waves tear through space. Any nearby planetary system gets a front row seat to absolute annihilation. Atmospheres get stripped. Surfaces get blasted. Anything resembling life gets reduced to a very short-lived experiment. But here's the twist that makes this less straightforward and more existentially confusing. Supernovae are also necessary. The heavy elements in your body, iron in your blood, calcium in your bones, those were forged in events like this. You exist because stars died violently enough to scatter their insides across the cosmos. So now we're in this uncomfortable position where the same phenomenon that can erase entire systems is also responsible for making life possible in the first place. It's like the universe has this habit of creating things through destruction, and we're just byproducts of that cycle. There's something darkly poetic about it. You are made of star stuff, sure, but that star stuff came from something that exploded with enough force to make entire regions of space regret being nearby. And it will happen again. It's always happening somewhere. Stars don't just shine, they're on a timer. Black holes. Black holes aren't cosmic vacuum cleaners, they're far more terrifying. Black holes are regions of space-time where gravity is so intense that nothing, not even light, can escape. There's a point in physics where explanations stop feeling like explanations and start feeling like threats. Black holes live there. You don't look at a black hole, you infer it, like a crime scene where the body's missing, but the damage is everywhere. Let's start with the event horizon, which sounds poetic until you realize it's basically a one-way door labeled good luck. Cross it, and every possible version of your future collapses into a single outcome: gone. Not destroyed in a dramatic explosion, not erased in some cinematic flash, just removed from the list of things the universe keeps track of. And before you even get there, things get weird. Spaghettification, yes, that's the actual term, which is somehow both hilarious and deeply upsetting. Gravity stretches you, not metaphorically, literally. Your feet feel a stronger pull than your head, and suddenly your body is less person and more cosmic noodle being slowly pulled apart by a force that does not care about your feelings. Time also stops behaving like a responsible adult. To an outside observer, you freeze at the edge of the event horizon, red shifting into oblivion, like a paused video buffering forever. But for you, time keeps going, which means from your perspective, you're falling in just fine. Smooth, continuous, no dramatic cutoff, just a quiet descent into something that physics refuses to fully describe without having an existential crisis. And then there's the singularity, the part where all the math breaks: infinite density, zero volume, a concept so aggressive it basically tells our current understanding of reality, you tried, you failed, sit down. Black holes don't chase you, they don't hunt, they just sit there, bending reality like it's soft clay, waiting for anything unfortunate enough to drift too close. Entire stars get shredded into glowing rings of screaming plasma, spiraling inward like they're being flushed down the most terrifying drain in existence. And yet, here's the part that sticks with me. They're everywhere. Not rare, not mythical, just scattered throughout the universe like landmines in a cosmic field. Which means the universe didn't just create something that breaks reality, it mass-produced it. Gamma-ray bursts. The deadliest weapon in the universe isn't a black hole, it's a flash of light. Gamma-ray bursts are the most energetic explosions in the universe, capable of sterilizing entire planets across vast distances. There's overkill, and then there's this. Gamma-ray bursts feel like the universe accidentally leaned on a button labeled Delete Biosphere and just left it pressed for a few seconds too long. They don't announce themselves, no warning sirens, no ominous buildup. 1 second you're on a perfectly normal planet, worrying about deadlines and awkward conversations, and the next, if you're unlucky enough to be in the path, your atmosphere gets hit with a beam of pure, concentrated energy so intense it rewrites the rules of survival. We're talking about a burst that can outshine entire galaxies. Not stars, galaxies. For a brief moment, something across the universe becomes the brightest thing that exists. And if that beam happens to line up with your planet, congratulations. You've just been selected for cosmic erasure. The radiation strips away your ozone layer like it's peeling plastic off a new phone. Suddenly, your planet is naked in front of its own star, exposed to levels of radiation that make sunburn sound like a joke. DNA breaks down. Ecosystems collapse. Food chains snap like cheap strings. And the cruel part? You might not even know what hit you. There's no monster to look at, no object to point to. Just a sudden, invisible wave of destruction that arrives at the speed of light and leaves behind a planet quietly transitioning from alive to not. Some theories suggest gamma-ray bursts could explain mass extinction events, which is a deeply uncomfortable thought. Imagine entire chapters of life on Earth just deleted because somewhere, far away, two neutron stars decided to merge in the most violently beautiful way possible. It's like the universe has these moments where it just clears its throat a little too aggressively, and entire worlds pay the price. No malice, no intent, just physics, having a really, really bad day. Vacuum decay. What if reality is only temporary? Vacuum decay is a hypothetical event where the universe suddenly collapses into a lower energy state, rewriting the laws of physics instantly. Okay, this one isn't even fair. At least with most cosmic horrors, there's distance, there's time, you can point to them, track them, pretend you have some level of control or understanding. Vacuum decay doesn't give you that courtesy. The idea, and I hate that this is even a valid idea in physics, is that the universe might not be in its most stable state. We could be sitting in a kind of temporary configuration, a false vacuum, which sounds harmless until you realize it implies there's a more stable version of reality waiting to happen. And when it does, everything changes instantly, no warning, no build-up, just a bubble of new physics expanding at the speed of light, rewriting every constant, every interaction, every rule that allows matter and you to exist in your current form. You wouldn't see it coming. You wouldn't feel it. By the time the information reached you, you'd already be different, or gone, or something that doesn't map onto human language anymore. It's not destruction in the explosive sense. It's more like the universe deciding to switch operating systems while everything is still running. Imagine waking up and gravity works differently, or atoms can't hold together the same way, or chemistry just stops cooperating, except you don't get to wake up and process that. The change outruns your ability to experience it. And the worst part? It could have already started somewhere far away. Right now. A bubble expanding across the universe, erasing everything in its path, heading in our direction with absolute indifference. No defense, no escape, no strategy, just the quiet, deeply unsettling possibility that reality as we know it is temporary. And one day, without warning, it might just stop. False vacuum bubbles. The end of the universe might already be here, and we'd never see it coming. False vacuum bubbles are expanding regions of space where the laws of physics have already updated, erasing everything they touch. This one doesn't knock, it doesn't announce itself with a dramatic sky crack or some cinematic ripple you can point at and say, "Oh, that's the end." No. This is a silent software patch for the universe, except instead of fixing bugs, it deletes the concept of you as a compatible file format. Picture a bubble, not a gentle soap bubble floating in sunlight, more like a perfectly smooth, invisible boundary racing outward at the speed of light. Inside that boundary, the rules are different. Constants change, forces behave differently. Chemistry might not even work, which means atoms, the basic building blocks of everything you've ever known, might not be stable anymore. So what happens when it reaches you? Nothing. Not in the way your brain expects. No explosion, no pain, no time to process. The information that the bubble exists cannot reach you before the bubble itself does. By the time any signal arrives, you're already inside it, already subject to laws that might not allow your structure to hold together. It's not destruction, it's incompatibility. Your entire existence is built on a very specific set of physical constants, like a delicate agreement between forces that decided, sure, let's allow matter to exist. A false vacuum bubble is that agreement being revoked, instantly, universally, and here's the part that makes this feel personal, even though it absolutely isn't. There's no villain, no cosmic entity making a decision, it's just stability seeking stability. The universe settling into a lower energy state, like a ball rolling downhill because that's what physics does. You don't matter in that equation, neither does Earth, neither does anything. We like to imagine the end of everything as loud, explosive, memorable. This isn't that, this is the universe quietly changing its mind, and you don't even get to notice. If you enjoyed this video or have any other suggestions, like and comment. To help me improve the content, subscribe so you don't miss out on more interesting content, and thanks for watching my video.